that I used in order to make my new haloalkane right here. Here I used hydrohalogenation with peroxides. This acts as a free radical addition to the alkene I formed. This addition is added on the least substituted side because regiochemistry is anti-Markovnikov with no rearrangements. Means that the addition will be on the most substituted side, and anti-Markovnikov means it adds to the least substituted side. Starts out as a hemolytic cleavage, which means that the bond between the two OH groups break and they get an even amount of distribution of electrons, where they become radicals, pictured here. Step where one of the radical chlorines form a bond with half of the electron from the double bond, and the other half of the electron on the double bond therefore become a radical carbon on the carbon right next to it. And our chlorine is added on that double bond where the double bond was broken. And there's a second propagation step where the same thing is repeated, but it's with the hydrogen and chlorine, and the bond is broken there, and the radical decides to bond with some electrons from that bond, where now the hydrogen is added onto our product. The last step is termination, where the chlorine bond, two chlorine radicals bond back together, and that ends this reaction. Form the newly formed haloalkane, right here, both of them, into an alkyne with 3 bonds by first turning into an alkene with terbutoxide, potassium terbutoxide. To form an internal alkyne, I use Br2 with the axis of N8 and H2 and H2O. I did this for both of my products. In order to form a Hofmann product. Hofmann means it favors the least substituted side, and Zaitsev means it favors the more substituted side. Then I transformed an alkyne to a ketone. I used H2O, H2SO4, HGSO4 to perform a hydration. The product formed a ketone due to its regiochemistry favoring Markovnikov, again where it favors the most substituted side. Below here is the mechanism. This is the mechanism between an alkyne and turning it into a ketone. So our triple bond right here acts as a nucleophile and attacks the hydrogen. The bond between the hydrogen and the OH2 group then breaks and attacks that carbocation. The electrophile. The next step, hydrogen then attacks that carbocation that was formed from us losing a bond on this carbon. Then a depertonation step occurs in this region where water is continuously used and it attacks the hydrogen and then breaks the bond between the oxygen, and then the bond donates to the oxygen with the positive on it. The next step right here, our oxygen donates an electron to this bond, and the bond is broken by donating to hydrogen, and the bond between OH and H are broken and then attacks that positive oxygen. The water attacks the hydrogen again, bond is broken, and then the bond donates to the positive oxygen, therefore forming our ketone. And that is shown right here as well on my second product. Took the ketone product and doubled the carbon chain via Grignard reaction. The first step was to form the Grignard reactant. The reactant was formed and it created C8, H18, MgBr that would react with my ketone. Below is the overall reaction of the ketone and the extended carbon chain with Grignard. 2 steps were used to form this new product, and that was Grignard was the MgBr attached to that carbon chain that I'm adding, the 8 carbon chain, and water. Start where this bond between the MgBr and the 8 carbon chain is broken when it attacks this carbon right here. When the attack happens, the bond off of the double bond will attack oxygen. This will attach my 8 carbon chain. A depertonation step occurs where oxygen, which is negative and it's a nucleophile, attacks my hydrogen. The bond between the hydrogen and the oxygen will break and the electrons will go onto the oxygen, therefore forming an alcohol product with that. So here is my alcohol Grignard reaction product with the byproducts. And this is replicated on my second E1 mechanism product. Lastly, I created two reactions, one with the Grignard alcohol product that was formed previously, using the TS chlorine and pyrimidine and NAF, which form these products. I then took this product to form another reaction, and I used NaOMe as my starting reactant, and the second one I used hydrogen 2 and platinum. It's called hydrogenation. Hydrogenation adds two hydrogens in syn addition. Syn addition means on opposite sides. My overall